Hey everyone, hope you're all doing very well and have made several high-speed passes with your radio-controlled vehicle in the 2024 RC season. With that being said, today's video is going to be about battery packs. This is by far the most recommended lithium polymer battery pack that we've ever had on the channel, and that is the SMC series racing packs. This is known as the SRD V3. This particular model is the 5300. I did select the 5300 because it's a little bit more inexpensive compared to some of the higher capacity batteries, and this will be very easily comparable with a lot of the packs that we've tested, where we've only tested between 4,000 and roughly that 5,800 milliamp hour mark. So this fits right in with that spec as well. And this SMC is a 14.8 volt, so it's a 4S, and it is known as a 250C pack. I don't think we'll get anywhere close to 250C, but let's test it because I have high expectations for these batteries. I know that these are very well known for the speed run guys to be running high performance setups and getting the lowest voltage drops from these specific batteries. This is also the first time that we're testing what I would consider battery packs that are in like the top tier of quality when it comes to lithium polymer technology. I also expect, even though we're not going to be testing this battery pack here in this channel for this specific purpose, I would expect that these batteries also live a longer life. You can get more cycle counts out of these specific batteries just because of the specific lithium polymer makeup of this lithium battery. So with that being said, I want to introduce the couple tests that we're going to be doing here, because a couple of you probably are new to the channel, and we do this on every single test. We create a log of all these different battery packs that we've tested, and I put that on my Patreon site so that anyone who is a member of the tier 2 subscriber, and you can download a copy of that spreadsheet for yourself. Now for the tests that we do two of them here on the channel. One is a load test and the other is looking at the internal resistance of the pack. Now this is a test that you can actually do at your own house. You could do it with your charger and using the spreadsheet that comes from the tier 1 Patreon site. So we're going to go through that here right now. So the first thing that we do is we have to set the charge rate for our charger, and we do this by multiplying the capacity of the battery pack there by 1.5, and this is where I get like 7.95 or 7.96, something like that, and I round it up to an even 8.0 because we're working in increments of 0.1 amps. And the next thing that I do is I make sure that I'm setting my voltage up to 4.20 volts. This is more for the test. You don't need to necessarily do this. I'm now also starting up the second battery. I have a nice power supply on there that makes tons of noise, and it's going to give us the capacity to charge both of these at this rate with no problem at all. So now that we got that started, you can see that the voltage is displaying. We got the current now displaying up to 8 amps, and we're going to take a look at this section of the screen where we can see the internal resistance of each one of those cells. What we do here is we do have to wait for a brief period. I speed that up, and once we get to that 1 minute mark, this is where this charger takes the internal resistance reading. We see 4.3 milliohms on the screen. Looking at what that breaks down to for the cell count, and the cells is 1.2, 0.8, 0.9, 1.1, those types of values. That is really, really good, and you can see by my thumbs up, I was really excited when I saw that, and I couldn't wait to see what this other pack was going to do and deliver for us. So we're just waiting for that to come up, and it shows up now, and it's showing about 0.9, 0.8 thereabouts for resistance, and very consistent. Again, there's the thumbs up because I am seeing that these packs are definitely going to perform better already than what we've seen in the past with batteries. This is the best internal resistance that we've seen during this test. We're going to go through the internal resistance and compute some form of C rating to give us a more realistic C rating of what this battery pack can deliver. So this is the RCexplained Tier 1 calc sheet. You can access this if you are a Tier 1 member and download a copy for yourself. As you can see along the bottom, there's a lot of different informational tabs to access different types of calculators. We're going to jump into the LiPo calculator and we're going to enter the information here. So on this sheet, we can determine the real C rating for our battery pack. We just need to enter in our data. The first bit of information we know is a 5300 milliamp hour pack. We need to put that in there. And then the average cell internal resistance of the LiPo battery pack. I'm going to take all 8 cells that we measured resistance on, and if you average it out, it becomes 0.95. When we take 0.95, it actually gives us a computed 35.2 C rated battery pack. And this gives you, if you work this backwards, 5.3 times 35.2 gives you a maximum continuous current of about 187 amps. And this is probably a little bit overdoing it. I don't really think that all the battery packs would be able to achieve exactly this, but believe me, when I say that this is going to be a lot closer to whatever you find on any battery label, this is definitely a lot more true and definitely something that you could be doing at home every single time with every new purchase that you make for a lithium polymer battery pack. Highly recommend it. So I'm going to run through the data and we're going to compare this against the CNHL. The CNHL battery pack is one that we've tested here on the channel at the end of 2023, and it has been one of the best performers, but I have a feeling this is going to beat it. Here we are with the actual load test. We got some data to run through and we are going to be comparing this up against the CNHL G Plus battery pack. So let's take a look at what we got to offer here from our SMC pack. We know that we started out with a 5300 milliamp hour pack and we have a C rating of a 250, and along the bottom you can see something that I've only recently added for this video, and that is a percentage of the original that we're comparing it to. So right now the CNHL, it has a capacity that is only 94.34% of the capacity for the SMC. The C rating is only 28% for the CNHL of that for the SMC. Now the SMC being 250, that is kind of a way out there type number that is not really expected to be accurate in the RC industry. So let's take a look at now the values that we have been able to achieve. Total milliamp hour that we got for the SMC was 4,832 under load versus the CNHL that it was only able to deliver 4,500 under load. This is a 93.5% difference. It's slightly lower than the actual capacity difference. So this means that you're actually squeezing out a little bit more capacity out of the SMC, probably because it can handle and maintain a higher amount of voltage there. So we have the milliamp hour to 3.50 volts. That's 2,526 out of the SMC versus 1780. The CNHL only delivers about 70% there to 3.50 volts. The time, very similarly, around 72%. It's 83.85 or 60.35, and the milliamp hour to 3.6, it's even worse. That's 62.28% for the capability that the SMC was able to deliver. And you get a very similar number for the time to 3.60 volts, being 40 seconds versus a 25.5. And what I meant there is the percentages are the same for this grouping because they're related, and this grouping, which is related, the 3.5 being around the 71% and these 3.6 being around the 64%. Then we take a look at the voltage at 10 seconds. Now what I've done for the percentage here is I've subtracted 3.3 from each one of these values and used those values to divide them, and you get 79.73%. That's because you will never achieve a value lower than 3.3 in this particular column. My voltage cutoff is 3.3, and if it hits it, that means that the battery has fully depleted or is suffering from too much of a voltage sag, and we have to ultimately determine what that is. And we can look at the graph to see what's actually happening here, and we'll see and talk about that very shortly. All of these numbers so far have essentially been a record broken for the test column that we've done on this channel. Energy per cell in watt minutes, over 1,000. This is again the number one for the first time ever where we've been able to achieve this out of a battery pack. And this is also a 5300, and the capacity there is very much in the realm of what we've already looked at and considered. The average cell wattage now that we're getting from this SMC, keep in mind this goes all the way to the end, including the very end of the LiPo battery pack that we're squeezing out right until that voltage cuts off, is 379 or so watts over the CNHL, which was 360.6. And this is per cell. Remember, there's 4 cells. You want to know how much average power we're getting at 100 100 and something amps, this would be multiplied by 4. And the last two values, the energy, 92% is what you get from the CNHL in comparison to the SMC. And then again, the CNHL only was able to deliver 95% of the average cell wattage in comparison to the SMC. So overall, when you look at all of these numbers except the label, which is probably the most disappointing part, the label itself, all you need to do is put on an accurate rating, get the battery packs out to people like me where we can actually show that these batteries definitely outperform all the other batteries. Like SMC is destroying everything that we've actually tested so far. Here's the data that actually proves it. The IR value, I shoved this right in the side here. It was 0.95. We haven't tested a battery pack at a 5,000 milliamp hour capacity with an internal resistance that low. All these values are really good and lend themselves very well for high demand applications like drag racing and speed runs for cars, speed runs for boats, and even oval racing for boats, because they do pull a lot of power under the entire duration of a battery pack. And you'll see more of that if you go over and head over to the Velocity Vision channel that I have. I'm going to be posting a lot of boat content in the next month or two. I got lots of video that I've taken. I just need time to sort through that. So when we're looking at these SMC battery packs, you look at the overall amount of current that we're delivering. It starts off at 100 and let's say 15 amps or so, and it slowly drops down to just about the 100 mark here near the very end of the battery pack. And then what we can see is it drops and tails off. This is definitely indicative of the battery pack reaching its point where there's no power left in the battery when we see that sharp drop off. So this does tell us that we've achieved full capacity under this load of the battery, which is really good in terms of performance. The fact that it stayed up above 100 amps until the very end is also showing very good. And the amount of current that it was able to put out is definitely around 105 amps or more in terms of the first 75% of this battery, because we don't want to drain it all the way to the end. We actually want to cut it off somewhere around this mark here is where we theoretically should be terminating the run that we're doing with these batteries. We don't want to deplete them past that 20 to 15% capacity remaining. Well guys, there you have it. We tested the first top tier battery pack, the SMC 5300. I hope you guys enjoyed this and now have evidence to support the difference there in batteries as we purchase them. I can't wait to get my hands on more top tier battery packs. Let me know in the comment section what you want me to test. Hopefully it is Canada friendly and I can get it into Canada fairly easily. And as always guys, like the video if you like what we're doing here for testing lithium polymer battery packs to help keep those manufacturers responsible when they're labeling their battery packs. And also if you subscribe, you won't miss the next video. Thanks a lot for watching. See you in the next one.